The Spectre vulnerability is a class of vulnerabilities exploiting speculative execution in modern CPUs. These vulnerabilities are categorized into multiple officially labeled variants, each targeting specific aspects of speculative execution. There are two main Spectre variants, with subvariants identified in follow-up research. These variants target different speculative behaviors in CPUs. Variant 1 of Spectre is the bounds check bypass. It's noted in CVE 2017-5753. It was identified during the initial Spectre research by Google Project Zero. It exploits speculative execution to bypass bounds checks on array or memory accesses. Speculative execution may access array index even if index is out of bounds. Data fetched speculatively leaves traces in the CPU cache, which attackers can analyze to infer sensitive information. It affects user mode and kernel mode memory isolation, and it's exploitable in browsers via JavaScript and similar environments. Mitigations include software and microcode. For software, compiler updates like inserting memory barriers like lfence or implementing speculative barriers. And microcode, hardware vendors provided firmware updates to reduce speculation. Spectre Variant 2 is branch target injection, noted in CVE 2017-5715. It was also identified by Google Project Zero. This exploits the CPU's indirect branch prediction mechanism. Attackers inject malicious branch predictions into the CPU's branch predictor to speculatively execute code at an attacker-controlled address. Results of the speculative execution leave observable side effects, like cache modifications, revealing sensitive data. It affects all modern CPUs with speculative execution and branch prediction. It's especially dangerous in multi-tenant cloud environments, where malicious code can influence branch predictors shared across virtual machines. Mitigations include the ret lines of replacing indirect branches with safe trampolines, microcode updates, restricting indirect branch prediction to prevent attacker control, and software updates, patching operating systems and hypervisors to minimize indirect branch speculation. Several subvariants and related discoveries extend or refine these initial Spectre variants. Variant 1.1, the bounds check bypass store, targets speculative stores that can overwrite data even if the main execution would prevent it. It was introduced as CVE 2018-3693. It's mitigated by stricter speculative barriers and updates to compilers. Variant 1.2 is the read-only bypass. It allows speculative overwrites of read-only memory. It highlighted additional risks in speculative paths, particularly in certain software architectures. Spectre is broader in scope than Meltdown, with multiple officially labeled variants targeting speculative execution mechanisms. Variants 1 and 2 are the core Spectre variants, each exploiting different CPU behaviors. Ongoing research continues to uncover additional speculative execution vulnerabilities inspired by Spectre. Understanding and mitigating these variants require a combination of hardware updates, operating system patches, and secure coding practices.